Hi, I'm Paul Battaglia. Welcome to section 2.8, quadratic models. I'm joined today by Carla and Dave. Thank you for being here.
Yeah, thank you, Paul.
And so Carla and Dave are going to help you plan out your lesson for section 2.8. And what we're going to do is a little different in this section. We're going to look at the same activity involving a basketball or a projectile of some sort, but Carla's going to give you a little bit more involved activity that you can do with your students if you have the kind of time and interest. And then Dave is going to take that same activity, modify it a little bit, simplify it if you really just want to make it a little bit more mainstream for your students. So Carla, why don't you lead us off?
Thank you. First of all, I'm all about the fun factor because math is not always...
Right, and we need to juice it up a little bit.
And my students every day will say, what does this have to do with life, right?
Yeah, right?
So I'm like, exactly. And I have a lot of sports people in my class. So I'm like, okay, fine, the quadratic model, I will take them down to our gym and it's like, let's just shoot some hoops. And then I've got one kid filming it.
Right.
So we're gonna go slow-mo. They think they're just having fun, but we're actually gonna bring it down and show them how they can graph it as we edit the film. And they think they've had a great day, but we're coming back into the classroom and actually doing some math.
And I think that's what we're trying to do. We're trying to get students to see how you can take this ordinary concept of a quadratic function and how you can see this in everyday life, how you can learn to plot it out, predict where the path of the ball might go. There's really an endless amount of things that you can do with this. Now, like I said before, maybe that's a little bit too involved. Maybe you don't have the resources, or maybe it's hard to get the resources when you need them. So Dave, give us a little bit more of a simpler model there.
Yeah, I mean, first of all, I think that's an amazing approach. I've done that before with my students. I love how it's really hands-on.
Right.
But like you said, sometimes maybe you don't have the time or the space to be able to do that. You could just do it in your own classroom with just a tennis ball or ping pong ball, where you just throw the ball into maybe a trash can, just to show them the same effect, the idea that the ball travels like a parabola, right? And to simplify, even without a camera, you could show them, if I start the ball here, right? That is the height of where you can measure to the ground. Maybe it's 4 feet off the ground. Right. That's the y-intercept, right? It ends up in the trash can across the room. How far is that? That would be the x-intercept. And then what's the highest point that this tennis ball reaches? That's the vertex. From these 3 points, you can show them how to work backwards to end up with the quadratic function. And I think it's great because then you can start showing them different variations of that. How you could throw a tennis ball into the basket with maybe a shallow curve versus throwing it higher up and then having it end up in the same place. And how different variations of this can give you different versions of the quadratic function.
And I think you can even, if you really want to have a little bit of fun with it, and I know, Carla, you love to do this, like you said, the fun factor, right? Let's have some competition. Let's get the groups, you know, trying to score some points by throwing these things, or maybe each group can exchange models, and then you can try and fit their model and see if you can kind of throw it on their path. So there's a lot of different things you could do with it. I think the one last thing that we're going to leave you with here is wanting students to understand whether or not their model is a good fit, right? So in order to do that, we want to make sure students understand the term coefficient of determination. We want to make sure that students know that this refers to how good of a fit the model is. And does it really represent what we saw, or is it kind of off a little bit? And it's okay if it's off. We want students to understand that's real life. You know, not everything happens according to plan, right? So I hope these tips have been helpful for you. Good luck in section 2.8.